June 6, 1944, 0630 hours, Omaha Beach, Normandy, France. Sergeant Philip Stretchick pressed his face into the blood-stained sand as machine gun fire ripped overhead, the distinctive sound of German MG-42s, 1,200 rounds per minute, turning the beach into a killing zone. Around him, the first wave of the 16th Infantry Regiment lay scattered, dead, dying, or paralyzed by terror. 30 yards ahead, through the smoke and spray, stood the reason for their immobility. A wall of Belgian gates, concertina wire stretched 8 feet high on iron posts, backed by wooden stakes and more wire, creating an impenetrable barrier that funneled American soldiers into pre-registered German killing fields. In Stretchick's pack was a weapon the Germans had never anticipated would reach this beach. 5 sections of steel pipe, each 5 feet long, packed with 8.5 pounds of TNT. The Bangalore Torpedo, a century-old design that British and Indian forces had used to breach wire in the trenches of World War I. The Germans knew about Bangalores. Their intelligence had documented them. Their defensive doctrine had planned for them. What the Germans didn't know was that of the 2,400 men who landed in the first wave at Omaha Beach, fewer than a dozen Bangalore teams had survived the approach. What they didn't know was that American industrial capacity had produced 50,000 of these devices and trained thousands of men to use them. What they couldn't have known was that in the next 6 hours, a handful of survivors would use this simple weapon to crack open the most heavily defended beach in Hitler's Atlantic Wall, transforming certain defeat into improbable victory. The story of June 6th at Omaha Beach is often told as a tale of courage overcoming obstacles. But the real story is more specific. It's about how a cylindrical steel tube packed with explosives, pushed through wire by men who had every reason to stay down, created the gaps that allowed 34,000 Americans to flood inland. It's about German defensive perfection meeting American industrial standardization. And it's about the moment when Oberst Kreis, commanding the 352nd Infantry Division from his headquarters at Château de Formigny, realized that his impregnable beach defenses were being systematically demolished by a weapon his engineers had dismissed as inadequate for the task. 3 miles inland, in the reinforced concrete command bunker overlooking the entire invasion sector, Oberst Dietrich Kreis reviewed his defensive preparations with satisfaction. As commander of the 352nd Infantry Division, he had transformed Omaha Beach into what he called a zone of absolute denial. The beach stretched 7,000 yards between the cliffs of Pointe du Hoc and Port-en-Bessin. Every yard was covered by interlocking fields of fire from 85 machine gun positions, 35 pillboxes, 18 anti-tank guns, and 6 artillery casemates. But Kreis's masterpiece was the obstacle system. The Atlantic Wall's beach obstacles had been designed by General Erwin Rommel himself during his inspection tour of early 1944. Rommel had studied the tide tables obsessively. At low tide, the beach was 300 yards deep. At high tide, it was barely 30 yards. The obstacles needed to destroy landing craft at all tide levels. Starting at the low water mark, German engineers had planted 2,608 obstacles in careful rows. Element C, steel frames shaped like massive jacks, 10 feet tall, designed to rip the bottoms from landing craft. Czech hedgehogs, steel rails welded together, immovable barriers weighing 600 pounds each. Belgian gates, iron frameworks filled with concertina wire. Wooden stakes, sharpened logs, angled seaward, many topped with teller mines. The mines were the killing touch. A landing craft hitting a mined obstacle would explode, killing everyone aboard. But even if landing craft made it through, even if soldiers reached the sand, Rommel had prepared something special. The shingle, the sloped bank of large stones that marked the high water line, was fronted by massive wire obstacles. 5-foot-high concertina wire, triple coiled, stretched for miles. Behind the wire, engineers had built a vertical seawall in some sectors, 4 feet of concrete that channeled troops into 5 heavily defended draws, the only exits from the beach. Major Werner Ploskat, commanding artillery batteries overlooking the beach, had walked the defenses in May with Oberst Kreis. The wire system particularly impressed him. Even if the Americans breach the obstacles and reach the shingle, they cannot advance, Ploskat observed. The wire will hold them at the waterline, where our machine guns can destroy them at leisure. Kreis agreed. The defensive plan was mathematically perfect. American soldiers landing at high tide would have 30 yards of open beach to cross under direct fire before reaching the seawall. Those landing at low tide would have 300 yards to cross, then still face the wire. Either way, the wire was the final trap, and breaching wire required specialized equipment, Bangalore torpedoes or engineers with explosives. Kreis's intelligence staff had calculated that the Americans would need at least 30 Bangalore teams to create enough gaps in the wire for an assault to succeed. German machine gunners had been specifically trained to target soldiers carrying the distinctive 5-foot pipes. The Americans would never get enough Bangalores to the wire. The mathematics of death were on Germany's side. What Kreis didn't know was that his perfect defensive calculations were about to collide with American industrial production numbers that defied German comprehension. The Bangalore Torpedo that would crack Omaha Beach had been invented in 1912 by Captain R.L. McClintock of the British Indian Army, serving in Bangalore, India. The device was remarkably simple. Steel pipes, 5 feet long and 2 inches in diameter, threaded at both ends so they could be screwed together. Each pipe section was packed with 8.5 pounds of TNT. A conical nose cone on the front section allowed the torpedo to slide under wire. A simple fuse on the rear section, either time delay or pull wire, detonated the explosive. The principle was elementary. Push the torpedo under the wire obstacle, light the fuse, take cover, and the explosion would blast a gap 6 feet wide through any wire entanglement. In World War I, Bangalore torpedoes had been standard equipment for trench warfare, creating passages through German wire for attacking infantry. By World War II, the basic design remained unchanged, a testament to its effectiveness. But the scale of production had increased exponentially. In 1918, British factories had produced perhaps 10,000 Bangalores for the entire war. In 1944, American factories were producing 50,000 Bangalore torpedoes, just for the Normandy invasion. The production took place at multiple facilities. The pipe sections were manufactured at steel mills in Pennsylvania and Ohio, precision-threaded to ensure sections from different factories would connect smoothly. The TNT came from munitions plants in Indiana and Tennessee. Assembly occurred at ordnance depots where workers, many of them women, carefully packed the explosive into pipes, installed fuses, and crated the completed torpedoes for shipment. Each Bangalore torpedo weighed 13 pounds. A 5-section torpedo, 25 feet long, weighed 65 pounds and could blast through the thickest wire entanglement ever built. The Americans had produced enough Bangalores to breach every beach obstacle in the Atlantic Wall twice over. The question was whether they could get them to the wire. Training with Bangalore torpedoes had been intensive. At the Assault Training Centre in England, every infantry company practiced wire breaching. The drill was simple, but required steady nerves. One soldier would crawl forward carrying the first section with its conical nose. Under covering fire, he would push it as far under the wire as possible. A second soldier would bring up additional sections, screwing them together until the torpedo extended completely through the wire obstacle. The last soldier would attach the fuse, light it or pull it, then everyone would take cover. The explosion, a bright flash and a sharp crack, would leave a gap through which an entire platoon could advance. The training emphasized speed and redundancy. Multiple Bangalore teams would approach the same wire obstacle from different points. If one team was killed, another would complete the breach. If one fuse failed, another torpedo would do the job. The American doctrine assumed heavy casualties among the breaching teams, but planned for success through overwhelming numbers. For Omaha Beach, the invasion plan called for 32 Bangalore teams in the first assault wave. Each 5-man team carried enough sections to assemble a 25-foot torpedo. The plan assumed 50% casualties among the teams, but the remaining 16 would create enough gaps in the wire for the assault to proceed. It was cold mathematics based on industrial abundance. Produce enough Bangalores, train enough teams, accept the losses, and eventually the wire would be breached. What American planners didn't anticipate was that German defensive fire would be so accurate and so overwhelming that 90% of the Bangalore teams would be destroyed before reaching the wire. At 0630 hours on June 6, 1944, the first landing craft ground onto Omaha Beach. The German defensive plan worked exactly as designed. The obstacles destroyed landing craft at the waterline. Machine gun fire swept the beach in pre-registered zones. Mortar shells landed among the struggling soldiers. Artillery fire from the heights added to the carnage. Within 10 minutes, the assault had stalled. Men who made it to the shingle hugged the small protection it offered, unwilling or unable to advance toward the wire 20 yards ahead. Sergeant Strechik had landed at 0640 hours with Company E, 16th Infantry Regiment at Easy Red Sector. His 5-man Bangalore team had been briefed on their specific target, a triple concertina wire barrier directly in front of exit E1, one of 5 draws that led off the beach. The landing craft's ramp dropped. German machine gun fire immediately killed the lieutenant, commanding Stredik's platoon, and half the men in the boat. Stredik grabbed his Bangalore sections and jumped into chest-deep water. Bullets churned the water around him. He saw men falling, some hit by fire, others drowning under the weight of their equipment. He made it to the beach and crawled forward, dragging his Bangalore sections. Around him, the carnage was beyond anything training had prepared him for. Burning tanks, exploding ammunition, wounded men screaming for medics who were themselves casualties. The beach was littered with equipment, backpacks, rifles, helmets, and bodies. He spotted another Bangalore team to his left. As he watched, all 5 men were cut down by a burst of machine gun fire from a bunker. Their Bangalore sections lay scattered on the sand, useless without men to assemble and detonate them. Strechik reached the shingle and found 20 men sheltering against it, pinned down by fire from at least 3 machine gun nests. A captain, the highest-ranking survivor he could see, was trying to organize the men. "We've got to get through that wire," the captain shouted over the noise. "Anyone got Bangalores?" Strechik raised his hand. The other 4 men from his team were nowhere to be seen, dead on the beach or drowned in the surf. But he had 4 pipe sections, not enough for a 25-foot torpedo that would reach completely through the wire, but perhaps enough to make a start. 3 miles inland, Major Pluskat watched the battle through his artillery observation scope. The beach was crowded with American soldiers, hundreds of them, maybe thousands. His gunners were firing as fast as they could load, dropping shells into the packed formations on the sand. Smoke obscured parts of the beach, but Pluskat could see that the assault was failing. The Americans were pinned at the waterline, unable to advance. The wire, he noted with satisfaction, was intact. Despite the naval bombardment that had preceded the landing, despite the aerial bombing, the wire obstacles remained largely undamaged. As long as the wire held, the Americans couldn't move inland. And without Bangalore torpedoes or engineers with explosives, the wire would hold indefinitely. But Pluskat noticed something that troubled him. Even as he watched, small groups of Americans were crawling forward toward the wire at different points along the beach. Some carried what looked like pipes, Bangalore torpedoes. He spoke into his field telephone, directing machine gun fire toward these groups. The gunners responded immediately. Bursts of fire cut down several Americans approaching the wire, but others kept coming. The Americans, Pluscat realized, were accepting catastrophic casualties to get those torpedoes to the wire. This was not the behavior of defeated troops. This was the determination of soldiers who believed they could win. Back on the beach, Sergeant Stretchick was assembling his Bangalore Torpedo behind the minimal shelter of the shingle. The captain had found 2 more soldiers with Bangalore sections, and together they had enough pipes to make a 20-foot torpedo, almost long enough to breach the wire. Another soldier, a private whose name Stretchick never learned, volunteered to help push it forward. The process was agonizingly slow. They screwed the sections together while machine gun bullets kicked up sand around them. Stretchick attached the conical nose to the first section. The private took the front end, Stretchick supported the middle, and they began pushing the torpedo under the lowest strand of wire. The wire was even more formidable up close than it had appeared from the water. Triple concertina coils, each coil 4 feet in diameter, with razor-sharp barbs every few inches. Behind the concertina was knife rest wire, X-shaped wooden frames wrapped with barbed wire. Behind that was more concertina. The obstacle was at least 15 feet deep. Their 20-foot torpedo would barely reach through it. They pushed the torpedo forward, inch by inch, feeling it scrape under the wire. A machine gun opened up, and the private helping Stretchick was hit. He fell across the torpedo without a sound. Stretchick kept pushing alone, shoving the pipe deeper under the wire, aware that at any moment a bullet could hit him or, worse, hit the torpedo and detonate it prematurely. Finally, the torpedo was positioned. The nose cone protruded from the far side of the wire barrier. Stretchick crawled back along the length of the torpedo to attach the fuse. His hands were shaking so badly he could barely thread the fuse assembly into the rear pipe section. He pulled the igniter pin, saw the fuse start to smoke, and scrambled backward. The captain grabbed him and pulled him behind the shingle. 5 seconds later, the torpedo detonated. The explosion was sharp and deafening, a white flash followed by billowing black smoke. When the smoke cleared, Stretchick looked up. Where there had been impenetrable wire, there was now a gap, roughly 6 feet wide, through which men could advance. The captain immediately started shouting, "Move! Move! Through the gap! We've got a breach!" But a 6-foot gap wasn't enough. German machine guns immediately covered it, firing directly into the opening. 3 men who tried to rush through were cut down instantly. The captain understood. They needed more gaps, multiple breaches that would overwhelm the German defenses. He looked down the beach. "Where are the other Bangalore teams?" Stretchick pointed to scattered pipe sections lying on the sand, the remains of teams that hadn't made it. The captain made a decision. "Gather those pipes. We'll make more torpedoes. Anyone who can move, start collecting Bangalore sections." This was the moment that decided Omaha Beach. Not heroic charges, but desperate scavenging. Soldiers crawled across the sand, collecting Bangalore sections from dead engineers. They dodged fire, grabbed pipes, and brought them back to the shingle. They found sections scattered from the water line to the wire, some still in the packs of drowned soldiers, others lying half buried in the sand. In groups of 2 or 3, soldiers assembled torpedoes from these scavenged sections. Some torpedoes were only 3 sections long, 15 feet, too short to breach the full depth of wire. Others were 6 or 7 sections, 30 to 35 feet, longer than needed. It didn't matter. Every torpedo that reached the wire created a gap. By 0730 hours, along a 200-yard stretch of easy red sector, 6 Bangalore torpedoes had been successfully detonated. 6 gaps in the wire, each one 6 to 8 feet wide, enough for men to pour through. The mathematics had shifted. German machine gunners couldn't cover 6 gaps simultaneously. As soon as they concentrated on one breach, Americans would rush through another. The wire barrier that Rommel had considered impregnable was being systematically dismantled by scavenged pipe sections and men willing to die pushing them into place. Oberst Kreis received the first reports at 0800 hours. multiple wire breaches at Easy Red, Americans advancing through gaps, machine gun positions reporting close combat. He studied his map. The wire breaches were concentrated in one area, but that was enough. Once Americans got behind the coastal defenses, they could attack the machine gun nests from the rear. He ordered his reserves forward, 2 companies from the 916th Grenadier Regiment. They would counterattack and seal the breaches. But Christ felt the first stirring of doubt. The Americans were supposed to have been stopped at the waterline. The wire was supposed to have been impenetrable without massive engineering support, yet they were breaking through with nothing but determination and those simple pipe bombs. What Christ couldn't see from his headquarters was the full scope of the Bangalore assault. All along Omaha Beach, wherever the wire barriers existed, American soldiers were assembling torpedoes from scavenged sections and blasting gaps. At Fox Green sector, a sergeant named Robert Blatnick assembled a 30-foot torpedo using sections from 3 different dead teams. The explosion created a gap that allowed his entire company to move inland. At WWII sector, a private named Leo Nash crawled 40 yards under machine gun fire, pushing a torpedo section by section, then detonated it to create the first breach in that area. At Charlie sector, 5 separate Bangalore teams, decimated but not destroyed, pooled their remaining sections and created 3 breaches in rapid succession. The process was neither clean nor coordinated. There was no unified command directing the wire breaching. Each small group of survivors acted independently, finding Bangalore sections, assembling torpedoes, pushing them through wire, and detonating them. Many torpedoes failed to explode, their fuses damaged by seawater or shrapnel. Some exploded prematurely, killing the men emplacing them. Others exploded successfully but in positions that didn't create useful gaps. But enough worked. By 0900 hours, there were at least 20 usable breaches in the wire along Omaha Beach. 20 gaps through which American soldiers were flowing inland, attacking German positions from unexpected angles, overwhelming strongpoints that had been designed to repel frontal assault but were vulnerable to flanking attacks. The German defensive doctrine had assumed that wire breaches would be isolated incidents that machine gunners could contain. But with 20 breaches spread across 7,000 yards of beach, the defenders were overwhelmed. They couldn't cover all the gaps. They couldn't prevent Americans from moving inland. German resistance remained fierce. Machine gunners fought to their last rounds. Concrete bunkers had to be reduced with satchel charges and flamethrowers. But the stalemate was broken. The Americans were off the beach, advancing up the draws, attacking inland. And it was Bangalore torpedoes, simple steel pipes packed with TNT, that had made it possible. By noon, Oberst Kreis understood that Omaha Beach was lost. His reserves had been unable to contain the American breakthrough. Allied naval gunfire was destroying his artillery positions. The wire barriers, his last line of defense, were breached in dozens of places. He reported to higher headquarters that the 352nd Division could no longer hold the coast, and requested permission to withdraw to secondary positions inland. The request was denied. Hitler's orders were to hold every meter of coastline. But orders couldn't change reality. The wire was down, the Americans were through, and the Atlantic Wall at Omaha Beach was broken. The human cost of the wire breaching was staggering. Of the 32 Bangalore teams that landed in the first wave, only 4 complete teams survived to the shingle. That's 20 men out of 160. But those 20 men, plus dozens of individuals who scavenged sections and improvised breaches, created the gaps that saved the invasion. The 16th Infantry Regiment, which led the assault at Easy Red, suffered 50% casualties on D-Day. The 116th Infantry Regiment at Dog Green sector lost 90% of its first wave. But by nightfall, 34,000 American soldiers were ashore at Omaha Beach, securing a foothold that would never be dislodged. The Bangalore Torpedo's effectiveness at Omaha Beach contrasted sharply with its performance at other D-Day beaches. At Utah Beach, where German defenses were lighter and beach obstacles less formidable, Bangalore torpedoes were barely needed. At the British beaches, Gold, Juno, and Sword, specialized armor vehicles called Hobart's Funnies took on most of the obstacle-clearing work. Flail tanks cleared mines, fascine-carrying tanks crossed ditches, and petard-armed AVRES demolished concrete obstacles. The British approach emphasized mechanical solutions to beach obstacles, reducing the burden on infantry. But at Omaha Beach, German defenses had destroyed many of the specialized tanks in the water. The duplex drive. Sherman tanks, designed to swim ashore, sank in rough seas. The few that reached the beach were quickly knocked out by anti-tank guns. This left the infantry to breach obstacles the hard way, with explosives and courage. The Germans' failure to prevent the wire breaching reflected a fundamental miscalculation about American capabilities. German defensive doctrine assumed that breaching operations required specialized engineer units with extensive equipment. The Germans hadn't anticipated that American training had distributed Bangalore torpedoes throughout the assault force. Every infantry company had multiple teams. Every soldier had seen Bangalores demonstrated in training. This democratization of capability meant that even when designated teams were destroyed, others could improvise breaches using scavenged equipment. More fundamentally, German doctrine didn't account for American industrial abundance. The Germans thought in terms of scarcity. Bangalores were specialized equipment, carefully rationed, used only by trained engineers. Americans thought in terms of abundance. Produce 50,000 Bangalores, issue them widely, train everyone in their use, and accept that most will be lost or wasted. The survivors will still be enough to do the job. This philosophy of overwhelming material superiority applied to the Bangalore Torpedo as much as to tanks, aircraft, and artillery. The Americans could afford to lose 90% of their Bangalore teams because they had brought enough Bangalores for the remaining 10% to succeed. Sergeant Strecik survived Omaha Beach and fought through the Normandy campaign. In a letter home written in July 1944, he described the wire breaching. The Bangalore was the simplest thing, just pipes with explosives. But it saved our lives and won the beach. I don't know how many times I've thought about those pipes sitting in some factory in Pennsylvania, workers packing them with TNT, never knowing that one of them would blow a gap in Hitler's Atlantic Wall. That's America right there. We build so many of everything that even when most are lost, enough get through to finish the job. Years later, interviewed for a military history project, Strecik was asked what he remembered most about D-Day. Not the fear or the casualties, though those memories never faded. What he remembered was the sound of Bangalore torpedoes detonating all along the beach, a rolling series of explosions that meant gaps were being blown, men were getting through, the attack was succeeding. That sound, he said, was the sound of American logistics overwhelming German defensive perfection. The technical specifications of the Bangalore torpedo were unremarkable, which was precisely why they worked. Each pipe section, 2 inches in diameter and 5 feet long, with 0.07 2-inch wall thickness, steel grade C1010 or equivalent, threading compatible with standard pipe fittings, weight per section 13 pounds. Explosive filling, TNT cast or pressed, 8.5 pounds per section, density 1.60 grams per cubic centimeter. Nose cone, steel, conical shape, threaded to fit standard pipe section, weight 2 pounds. Fuse assembly, M1A1 pull friction lighter or M2 time fuse installed in rear section cap. The simplicity meant production was straightforward and rapid. No complex machining, no exotic materials, no specialized assembly procedures. A moderately equipped factory could produce hundreds of Bangalore torpedoes daily using standard steel pipe production methods. The explosive charge was calculated to maximize wire cutting while minimizing earth excavation. 8.5 pounds of TNT per 5-foot section created a blast that would sever wire up to 3 feet from the pipe. A 5-section torpedo, 25 feet long, with 42.5 pounds of TNT total, would clear a path 6 to 8 feet wide through any wire entanglement up to 25 feet deep. The explosion's effectiveness came from placement, not power. By positioning the charge at ground level directly under the wire, the blast energy focused upward into the obstacle. The wire, stretched taut between posts, absorbed the full force of the explosion. Even thick cable wire, which could withstand small arms fire, would be severed by the blast. The wooden or metal posts supporting the wire would be shattered or bent. The net effect was a clean gap through which troops could advance immediately after the dust cleared. The fuse system's reliability was critical. 2 fuse types were standard. The M1A1 pull friction lighter was the simplest, a friction igniter that the soldier pulled to light a pyrotechnic delay element. After a 9-second delay, the explosive detonated. The soldier had time to take cover, but not enough time for defenders to disrupt the torpedo. The M2 time fuse allowed preset delays from 5 to 30 seconds. This flexibility let soldiers adapt to tactical situations. A short fuse prevented Germans from cutting the torpedo free or disarming it. A longer fuse gave the team more time to reach cover in situations where German fire made immediate withdrawal necessary. The fuse reliability rate was approximately 95% under ideal conditions. In combat, with fuses subjected to water immersion, shock, and rough handling, reliability dropped to perhaps 75%. This was why doctrine emphasized redundancy, multiple torpedoes against the same obstacle to ensure at least one would function. The German defensive response to Bangalore torpedoes evolved as the Normandy campaign progressed. After D-Day, German engineers studied captured torpedoes and developed countermeasures. They increased wire depth, creating obstacles 30 to 40 feet deep that would require longer torpedoes. They added more wire layers with gaps between them, hoping to catch torpedoes in the first layer before they reached deeper obstacles. They scattered loose wire on the ground in front of obstacles, creating snag points that would prevent torpedo advancement. They positioned machine guns to cover the most likely approach routes to wire obstacles, concentrating fire on soldiers carrying pipes. None of these measures proved decisive. American engineers responded by producing longer Bangalore torpedoes, up to 50 feet when needed. Soldiers adapted by assembling torpedoes in covered positions, then pushing them rapidly into place. The fundamental effectiveness of the weapon, its simplicity and reliability, meant that countermeasures only increased casualties without preventing breaches. The production statistics for Bangalore torpedoes during World War II revealed American industrial capacity. Total production 1942 to 1945, approximately 250,000 complete torpedoes. Monthly peak production, March 1944, 18,000 units. Primary manufacturers, Watertown Arsenal, Massachusetts, Rock Island Arsenal, Illinois, numerous contracted steel pipe manufacturers. Cost per complete 5-section torpedo, approximately $15 in 1944 dollars. This remarkably low cost meant Bangalores were treated as expendable. Units would request and receive hundreds at a time, use them freely in training, and deploy them in abundance for operations. The contrast with German engineer equipment was stark. German Goliath tracked mines, small explosive robots used for similar obstacle clearance, cost over 3,000 Reichsmarks each, required specialized training, and were in chronically short supply. A single German assault engineer battalion might have a dozen Goliaths. An American infantry regiment would have hundreds of Bangalore torpedoes. The training program for Bangalore torpedoes was embedded throughout the infantry preparation cycle. At basic training, soldiers learned Bangalore fundamentals, the parts, assembly, and basic deployment. At advanced infantry training, they practiced breaching actual wire obstacles under simulated combat conditions. At unit training in the United Kingdom before D-Day, assault companies ran full dress rehearsals with live Bangalores against replica German obstacles. This progressive training meant that by D-Day, even privates had assembled and detonated multiple Bangalores. When specialized breaching teams were wiped out on Omaha Beach, ordinary riflemen could take over the task because they had the training and the confidence to do it. This was American training philosophy: disseminate skills broadly rather than concentrate them in specialist units. Make every soldier capable of basic combat engineering. Accept that specialists will do the job better, but ensure that when specialists are casualties, others can continue. The psychological impact of Bangalore explosions on both sides was significant. For American soldiers pinned down on Omaha Beach, each explosion signaled progress. A gap blown meant movement possible, the attack continuing, hope surviving. The sound of Bangalore's detonating became a rallying point. Soldiers would hear an explosion, see smoke clearing from a wire breach, and move toward it without orders. The explosions created their own coordination, marking points where the advance was succeeding. For German defenders, Bangalore explosions signaled the failure of their wire obstacles. Machine gunners who had felt secure behind impenetrable wire now watched Americans flowing through gaps. The explosions were also unnerving, because they indicated that despite tremendous casualties, the Americans kept attacking. Each Bangalore breach meant a team of soldiers had crawled close enough to emplace the device, survived long enough to detonate it, and created a gap that others would exploit. This persistence, this willingness to continue attacking in the face of heavy casualties, shook German confidence in ways that better weapons alone couldn't achieve. The technical evolution of the Bangalore Torpedo during the war showed American adaptability. The basic design remained unchanged, but variations appeared for specialized situations. Extended torpedoes, up to 10 sections, 50 feet long, for extra deep obstacles. Waterproof torpedoes with sealed joints and protected fuses for beach assaults. Lightweight torpedoes using aluminum pipe for airborne operations where weight was critical. Triple-charge torpedoes with reinforced sections holding 15 pounds of TNT each for concrete obstacles. None of these variations saw mass production, but their existence showed that American engineers weren't satisfied with a working design. They continued improving, experimenting, and adapting the Bangalore to different tactical requirements. This drive to improve everything continuously gave American forces incremental advantages that accumulated into decisive superiority. The Bangalore Torpedo's effectiveness at Omaha Beach validated pre-war American engineering philosophy. The U.S. Army's Ordnance Department had studied World War I lessons and concluded that simplicity and abundance were more valuable than sophistication and scarcity. Rather than develop complex mechanical mine clearers or wire cutters, they chose to mass-produce a 1912-era design that was proven, simple, and reliable. This decision wasn't glamorous. No engineer earned a promotion for recommending production of an old-fashioned pipe bomb. But on June 6, 1944, when sophisticated equipment failed or was lost, the simple Bangalore Torpedo got the job done. This lesson, that proven simple designs deployed in abundance often outperform sophisticated equipment in limited numbers, would be relearned throughout the war and in subsequent conflicts. By evening on June 6th, Omaha Beach was secured. The initial 34,000 men were ashore, expanded to 55,000 within 24 hours. The beachhead, only 1.5 miles deep at some points, was barely adequate. But it was enough. Reinforcements poured in, supplies accumulated, and the breakout toward the Normandy interior began. The beach obstacles that had seemed so formidable at dawn were already being cleared by engineers with bulldozers. The wire barriers that had stopped the first wave were trampled into the sand by thousands of boots. The gaps that Bangalore torpedoes had blown were widened into highways. The Atlantic Wall at Omaha Beach, Rommel's masterpiece of defensive engineering was reduced to debris. German after-action reports from the Normandy campaign consistently cited American engineering capabilities as decisive. One captured 352nd Division staff report stated, "The enemy possesses unlimited quantities of specialized demolition equipment. His Bangalore torpedoes appear in such numbers that every obstacle we construct is immediately breached. Our wire barriers, which should require hours to clear, are destroyed in minutes. We cannot build obstacles faster than American engineers remove them." This assessment reflected German frustration with American material abundance. The Germans could design better defenses, employ superior tactics, and benefit from prepared positions. But they couldn't match American ability to bring overwhelming quantities of equipment to bear. Bangalore torpedoes were just one example of this disparity, but a revealing one. The simplest demolition device, produced in staggering numbers, distributed widely, and employed persistently, overcame elaborate German engineering. The men who used Bangalore torpedoes on D-Day came from every background. Sergeant Stretchick was a steel worker from Pennsylvania. Private Nash was a farmer from Iowa. The unnamed soldier who died helping Stretchick push the first torpedo was from Brooklyn, worked in his father's grocery store. They weren't combat engineers or specialized demolitioneers. They were ordinary infantrymen given an explosive device and told to breach wire. That they succeeded, that they crawled through machine gun fire carrying 60-pound loads of TNT, that they assembled torpedoes under fire and detonated them while Germans tried to kill them. This reflected American military culture. Initiative was valued over rigid procedure. Individual action was encouraged when unit cohesion broke down. Soldiers were trained to think, improvise, and adapt rather than wait for orders from superiors who might be dead. This decentralized decision-making proved decisive at Omaha Beach. When the assault plan collapsed, when command broke down, when designated breaching teams were casualties, individual soldiers picked up the mission. They found Bangalore sections, assembled them, and completed breaches without orders because they understood that breaching the wire was essential to survival. German military culture, by contrast, emphasized obedience and procedure. German soldiers would rarely act without orders. German engineers wouldn't attempt missions outside their specialization. This meant that when German defensive plans worked, they worked magnificently. But when plans failed, German units struggled to adapt. Americans excelled at chaos. They thrived when structure collapsed because their training emphasized adaptability over conformity. The after-action interviews with Omaha Beach survivors revealed a common theme. Soldiers described the beach as chaos, but purposeful chaos. Everyone knew the mission: get off the beach, breach the wire, move inland. When leaders were killed, others led. When plans failed, soldiers improvised. When equipment was lost, they scavenged. The Bangalore torpedoes exemplified this chaos. No one was tracking how many torpedoes were deployed or where gaps were blown. Soldiers simply gathered pipes, made torpedoes, and blasted gaps wherever they found wire. The lack of coordination didn't matter because the goal was clear: create enough breaches that the attack continues. Each individual breach might be uncoordinated, but cumulatively they achieved the objective. This emergent order from chaos was something German military doctrine couldn't comprehend. The historical debate about Omaha Beach often focuses on command decisions, naval gunfire support, and whether the assault should have been postponed. But soldiers who were there point to a simpler factor. The Bangalore torpedoes worked. Bangalore torpedoes got through the wire. Bangalore torpedoes created the gaps. Without those gaps, no amount of naval gunfire or air support would have gotten men off the beach. The wire would have held them at the waterline where German gunners could have destroyed them methodically. The Bangalore torpedo, a weapon so simple that it hadn't changed since 1912, was the key that unlocked the Atlantic Wall. Not because it was sophisticated or powerful, but because it was simple, reliable, and available in numbers that overwhelmed German defenses. The legacy of the Bangalore Torpedo extended beyond D-Day. The weapon remained in U.S. military service through the Vietnam War and beyond. Modified versions are still used by some armies today for breaching obstacles. But the true legacy isn't the weapon itself. It's the philosophy the weapon represents. Simple, proven designs, produced in abundance and employed by trained soldiers with initiative, can overcome sophisticated defenses. This lesson learned at Omaha Beach would shape American military procurement for generations. The question wasn't whether a weapon was the most advanced, but whether it was reliable, producible, and effective. The Bangalore Torpedo, with its century-old design and $15 price tag, was all three. Sergeant Stretchick returned home after the war, went back to the steel mill, and rarely spoke about his experiences. In 1994, for the 50th anniversary of D-Day, a historian tracked him down and asked about the Bangalore Torpedo. Stretchick's response captured the weapon's significance. "That pipe saved my life, saved hundreds of lives, maybe saved the whole invasion. It wasn't fancy. It was just a steel tube with explosives. But it did exactly what it was supposed to do. It blew a hole in that wire. And that's all that mattered. Sometimes the simplest answer is the right answer. We had wire. We needed gaps. The Bangalore made gaps. Everything else is just details." The German soldiers who survived the Omaha Beach defenses carried different memories. Captured members of the 352nd Division expressed shock at American persistence. A machine gunner named Klaus Weber later testified, "We killed so many of them, but they kept coming. Every time we thought the attack had failed, more Americans would appear. They seemed to have unlimited men and equipment. The torpedoes especially, we would destroy one team, but another would come with more pipes. Where did they get so many? We couldn't understand how they kept attacking when victory seemed impossible." For Weber and his comrades, the Bangalore torpedoes represented something more than a demolition tool. They symbolized American material abundance that rendered German tactical excellence meaningless. The story of the Bangalore Torpedo at Omaha Beach challenges simplified narratives of D-Day. The invasion wasn't won primarily by heroic charges or brilliant tactics. It was won by logistics, industrial production, training, and soldiers who did unglamorous but essential work under fire. Blowing gaps in wire wasn't heroic in the cinematic sense. It was technical work requiring steady nerves and training, but without those gaps, the heroic charges would have failed. Without Bangalore torpedoes, Omaha Beach might have been a catastrophic defeat instead of a costly victory. The weapon that changed D-Day wasn't revolutionary technology. It was a century-old design, produced in Pennsylvania factories, shipped across the Atlantic, distributed to infantry companies, and used by ordinary soldiers to solve a tactical problem that German engineering thought was unsolvable. In the final analysis, the Bangalore Torpedo at Omaha Beach represented the collision of two different military philosophies. German forces emphasized engineering perfection, elaborate defensive systems designed to create insurmountable obstacles. American forces emphasized productive abundance, simple tools produced in overwhelming numbers to overcome any obstacle through persistence and material superiority. On June 6, 1944, those philosophies met on a beach in Normandy. The wire barriers were perfectly engineered, positioned to maximize defensive advantage, backed by interlocking machine gun fire. The Bangalore torpedoes were simple pipe bombs, nothing more than steel tubes packed with TNT. The torpedoes won because American soldiers, trained to use them and equipped with unlimited supplies, kept pushing them through wire until enough gaps existed to break the defensive line. That afternoon, as American troops advanced inland through the gaps that Bangalore torpedoes had created, Oberst Kreis realized the fundamental truth that would define the war's outcome. American victory wasn't about superior tactics or better soldiers. It was about industrial capacity, about producing more of everything than Germany could destroy, about accepting casualties that would break other armies because reserves were unlimited. The Bangalore Torpedo epitomized this advantage. Germany might design better weapons, build stronger fortifications, train better soldiers. But America would produce 250,000 Bangalore torpedoes, distribute them throughout the invasion force, and ensure that enough survived to complete the mission. Against such abundance, German perfection was inadequate. The wire barriers at Omaha Beach, Rommel's final trap, were designed to channel American forces into killing zones where German machine gunners could destroy them. Instead, Bangalore torpedoes blew 20 gaps, then 30, then dozens, until the wire barrier ceased to be a barrier at all. Each gap represented a 5-man team that had carried pipe sections through fire, assembled a torpedo under bombardment, pushed it through wire while Germans shot at them, and detonated it successfully. Each gap represented American industrial capacity that produced the torpedoes, American training that taught soldiers to use them, and American logistics that delivered them to the beach. Each gap was a small victory of material abundance over defensive sophistication. Collectively, those gaps decided the battle. The Bangalore torpedo that broke through Omaha Beach's defenses was remarkable only in its simplicity and availability. It wasn't the best demolition device theoretically possible. It wasn't sophisticated or innovative. It was a 1912 design, unchanged and unimproved for 32 years, produced in staggering quantities and used by soldiers who had trained with it extensively. That combination, simple design plus mass production plus widespread training, created a capability that German defenses couldn't overcome. The pipe sections that Sergeant Stretchick screwed together on Omaha Beach had been manufactured in Pennsylvania steel mills by workers who never saw combat. The TNT had been produced in Tennessee munitions plants by women who would never visit Normandy. The fuse had been assembled in Massachusetts by workers who couldn't have pointed to Omaha Beach on a map. But their work, combined with Stretchick's courage and training, created a 6-foot gap in Hitler's Atlantic Wall. That gap, and dozens like it, made D-Day successful. The lesson of the Bangalore Torpedo at Omaha Beach remains relevant. In war, simple solutions deployed in abundance often outperform sophisticated solutions in limited numbers. A $15 pipe bomb, produced by the thousands, distributed widely, and used by trained soldiers with initiative, achieved what no amount of naval gunfire or aerial bombing could accomplish. It breached the wire, created the gaps, and allowed the invasion to continue. Everything else, the courage, the casualties, the command decisions, these mattered tremendously. But without gaps in the wire, none of it would have succeeded. The Bangalore Torpedo created those gaps. It was the key that turned in the lock of the Atlantic Wall and opened the door to victory in Europe. Simple, proven, available in numbers, and used by soldiers who understood their mission and adapted when plans failed. That was the real story of D-Day at Omaha Beach, told through the lens of a century-old pipe bomb that changed history.